So the third rule, so the first rule was the constant rule, then we did the power rule. The third rule is the constant multiple rule. Retreat. And we've seen versions of this sort of with limits. Remember, a derivative is all based around a limit. If I have a constant being multiplied by a function, just like in limits, you can pull the constant out. Okay? So I can rewrite this as c times the derivative of f of x. Or you can write, if you want, c times f prime of x. All means the same thing. So if you have this 2 here, 2x to the fourth, and I want to know what y primed is. Oops. Basically, ignore the 2, essentially pull it out. So you just rewrite the 2 right there. And then do the derivative of x to the 4. What's the derivative of x to the 4? 4x cubed. And then you just multiply the 2 and the 4, which you can do in one step, obviously. You don't have to do this in 2 steps. So you can just write 8x cubed. Is that okay? All right. B. Four-fifths t cubed, exact same thing. It's a fraction, might look a little different, but it's the same thing. The derivative is going to be, forget about the constant, just rewrite it. Drop the 3 down, take 1 away, so it's 3t squared. And then you can multiply the 4/5 and the 3 to get 12/5 t squared. Right. C. What do we not like about C? We got a square root and our variables in the denominator as well, right? Neither of which we like, so we need to rewrite it. What do I rewrite it as? What does a square root mean in terms of an exponent? 1/2. If it's in the denominator, how do I flip that up? You make it negative, right? So the 1/2 stays there. You don't touch that. So it's like 1/2 times x to the negative 1/2. And now you do your derivative. So we leave the 1/2. you don't have to worry about the constant. Drop down to negative 1/2. Take 1 away from negative 1/2. What do you get? I heard some mumbling. I think I heard the right answer somewhere. Negative 3/2. Right? Because it's negative 1/2 minus 1, which is what's positive 1/2 times negative 1/2? So I get negative 1/4. You could just leave it like this. That's perfectly acceptable answer. Or if you really wanted to, you could write it like this. Same thing. I don't really care what you do. Either one of those is fine. The second one, this one here, when you're subbing stuff in, might be a little easier to deal with. All right, but they're both acceptable answers. All right. D. What's the derivative of that? Hmm? 1. Because you drop the 1 down, be x to the 1 minus 1, which is x to the 0, which is 1. So the derivative of x just by itself is always 1. All right, what if we have this? We need to simplify this because we haven't done anything like this yet. So what should we do? You don't know what to do? You can factor. So you can, what can you factor out of the top? Pull an x out. Whoa. Then those disappear. And we've simplified it to this. Now, if you remember when we were doing limits, which a derivative is, right? So the limit rules apply. If you're adding or subtracting, you can do each limit separately. And now that means we can do each derivative separately. So what's the derivative of x squared? 2x. What's the derivative of 2x? 2. What's the derivative of 1? 0. So that's your derivative. Does that make sense? Just deal with each one separately when you're dividing. One more. Now we need to rewrite this. If now you can factor, it's the same thing as the one above. Most people don't really recognize that you can factor that. So if you have a single denominator, what you can do is rewrite it like this. Just like the limit stuff, we're adding, we're subtracting, so that denominator goes to everything. And then you simplify. What do you do with the exponents if you're dividing? Subtract. So So the first one becomes 7x squared minus 3x to the negative 4, 4x to the negative 1. And now we can just do each derivative separately. So the derivative of 7x squared is 14x, right? The 2 drops down, multiplies by the 7, and you take 1 away from the 2, so you get 14x. What about second bit? Negative 4 drops down, multiply by negative 3 to get 12x. Take 1 away from the exponent to get negative 5. And the last one, drop the negative 1 down. So I get negative 4x to the negative 2. Any questions about that? All right, here's your practice. We have one tiny more thing to do after this, and then that is it. Page 114, 3 to 17, odd, 43, 45, 55, and 57, please. Sorry? Yeah.